All right, guys, here we are, the last video of the semester. That's kind of sad a little bit, even though I never actually really see you guys face to face. It's still somehow sad. I don't know. Anyways, here we go, guys. Last two questions. Although the last one is actually several questions. 32 first. If a certain radioactive substance starts with 50 grams and after 24 hours has decayed to 20 grams, what is the half-life of the substance? Use the formula A equal to P equals EPERT. So first of all, let's just write our equation down again. A is equal to PE to the RT. And let's just fill in the information that we know. So we know that it started with 50 grams and it decayed to 20 grams. So 20 is the end result, right? This is the starting. P is the starting result. A is the end result. E is just a constant. R we do not know, but T we know is 24 hours for that decay to occur, right, from 50 to 20. So looking at this equation, the only thing that is an unknown is the R. So that kind of tells us what to solve for without even without really understanding the question almost. You can just fill in the formula, fill in the parts that you're given, and then you kind of know what you should solve for first. So let's go ahead and do that. And to do that, first thing I'm going to do is just divide both sides by 50. And then that's going to give me 2/5, right? 20 divided by 50 is 2/5. Equals to E to the, I'm going to rearrange these guys, and instead of R times 24, I'm going to write that as 24R. Okay, now, to solve this thing, I want to bring this R out of the exponent. So to do that, I'm just going to hit it with the ln, the natural log, right? The ln is going to, on the left side, it's going to just do ln of 2/5. And on the right side, it's going to undo the E. So ln of E, undoes each other, so you just get to 24R. And then finally divide by 24 on both sides. So R is ln of 2/5 over 24. So there you go, there's your R. Now, let's look back at the question though. The question didn't ask us for R actually, but it did ask us for the half-life. So what does that mean? Okay, that means half-life is a time, right? It's T. But here I just solved for R. So what is the connection here? What we're going to do is we're going to rewrite our formula again. A is equal to P e to the RT. Let's fill in the pieces we know this time with this half-life in mind. So I'm looking for half-life. What does that mean? It means this end result should be a half of what it started as, right? So the P is the original whole, finishing with a half of that whole. E is just a constant, excuse me. And R is this quantity that I just finished solving for. So I know R, I know all the other letters. The only thing I don't know is that T. Okay, meanwhile, guys, I'm plugging that into my calculator, that ln of 2/5 divided by 24 to get an approximation for me to just plug in here. So that's going to be negative 0.03817 87805 T. Okay, now I'm going to just do the same thing as last time. I'm going to solve this for T now this time, T, right? And, this 1, I didn't really need a 1 there. Hit both sides with the ln. The left side, you're going to end up with ln of 1/2. The right side, ln undid the E, so you're left with negative 0.03817878805 T. Divide both sides by this big number, not big number, but that long decimal. And that's going to give you your T. ln of 1/2 over that whole thing. Okay, now lastly, let me punch that into the calculator. Let's see, ln of 0.5 divided by, I'm going to recall my answer actually to get a most accurate result. And I'm going to end up with this. T is approximately 18.155. Now, let's see, how much should be round here? We were given originally time in 24 hours. So I don't want to go too far past that. Let's just say to the nearest single decimal. So let's say T approximately 18.2 hours. I'm not following here the rules of significant figures, but just using a little intuition. Okay, so there you go. About 18.2 hours. And let's just think for a second. Does that kind of make sense? Well, after 18.2 hours, if you start with 50, that means you would have been down to 25 grams, right? So a little longer than that, 24 hours would bring you down to 20 grams. That makes sense. That sounds reasonable. So that's not it's not an exact check, but just a quick check to make sure that the answer seems reasonable. And yeah, that seems about right. Oh, one more small note. If you want to, you can write this as T sub 1/2 because that's the notation for a half-life. But you don't have to. You can just keep it as T. It's fine. All right, so that was 32. And then now 33 is a bunch of questions in one. And for sure, you can expect to see at least one of each type. One of the exponential type, one of the logarithmic type, at least one, but probably more than that, I'm thinking. Because we've spent a bunch of time doing a bunch of examples on the homework for that one, I remember. What was that, 3.4? Okay, anyways, here we go. Let's go 33. Question A first. I don't know why I just realized these directions are kind of weird. This solve the equation should have gone, I think, before the letters, because that's what we're doing for all of these letters. But never mind. You guys know what to do, right? Okay, 5 to the x plus 1 is equal to 625. And okay, this is one case. These kind of questions, you could technically just go ahead and hit it with the ln, or hit it with the some kind of log to bring that exponent down. But if you do notice that this number is a power of 5, then that will be helpful. And that is 525, 125, 625, 5 to the 4th. That's 5 to the 4th. So 5 to the x plus 1 is 5 to the 4th. And if you make that recognition, then x plus 1 equal to 4, right? Because if 5 to something equals 5 to something, then that means those exponents must equal to each other. So x plus 1 equals 4, which means x equal to 3. As simple as that. But, again, I mentioned this last time we did questions like this. If you did not recognize that, it's actually not too big of a deal, because you could still do it the old-fashioned way and just hit it with the ln. What happens then? Exponent comes out to the front, right? So I've got x plus 1 ln of 5 equals to ln of 625. I can divide both sides by ln of 5, and I get x plus 1 is equal to ln of 625 over ln of 5. And then lastly, just subtract 1 from both sides, and I get x equal to ln of 625 over ln of 5, and then minus 1. And you can just plug that into your calculator and see that it works. Or alternatively, you could also use a reverse change of base here. Because all this guys is kind of extra. I would ideally you make the recognition and you just do this work, super easy. But if you don't make the recognition, just do the same routine thing and hit it with the ln until you get to this point, then punch it into your calculator and you should get the right answer. If you want to take a step further and simplify without a calculator, you could though, because here you have this form that I just wrote. It looks like the change of base, right? Remember, change of base takes the top over the bottom. So in particular, let's change this to log back of 5, because this is the bottom one, right? The top one over the bottom one. So the bottom is the 5 and top is 625. And that's equal to 4, because 5 to the 4th is 625. So 4 minus 1 is equal to 3. So you got the same thing. Okay, I did more work than was necessary here, which is not a good idea when I'm trying to save time, but maybe I'm trying to prolong this last video. I don't know. Okay, so there you go. That was the ideal work, but you can still get by if you don't make that recognition that 625 is a power of 5 and just go the route of hitting everything with ln's, just like blasting everything with your sledgehammer. That always is going to work, just might not be the most efficient. Okay, that was A. Letter B now. 3 to the x is equal to 23. This is a case where 23 is definitely not a power of 3. So the thing that makes sense is to just start right away by hitting it with the ln. Exponent comes out is in front as a multiplier. That's really the key factor or key what do you call property of logs, right? Is logs will bring down an exponent as a multiplier in front. So I get x ln of 3 equals ln of 23. So that means x is ln of 23 divided by ln of 3. All right, let's get an approximation for that. Ln of 23 divided by ln of 3. And it's approximately 2.8540. So there you go. That's part B. On to part C now. Okay, 2 to the x plus 4 equals to 3 to the x plus 1. So remember, exponent equation, we hit it with the ln's. If you prefer log, base 10 is okay. But I always just go to log, base e or ln. So remember, ln brings the exponent down as a multiplier. X plus 4, ln of 2, right? This one is x plus 1, that's the exponent, ln of 3. And now I gotta do a little algebra here to get my x's by themselves. So first thing I gotta do is I gotta distribute this thing, or distribute that, whichever way you wanna look at it. I got x ln of 2 plus 4 ln of 2. On the right, I got x ln of 3 plus ln of 3. That's what happens if you just FOIL out, right? Just multiply out. Okay, now I'm going to gather things that have x's in them. So here on the left, I have x ln of 2 minus x ln of 3. That's this guy and this guy. And on the right-hand side, I have, let's just change color halfway so I can see the distinction. It's going to be ln of 3 minus 4 ln of 2. Yeah, see that? Okay, and then now factor out an x out, this guy, right? So I got x ln of 2 minus ln of 3 equals to ln of 3 minus 4 ln of 2. Lastly, just divide by this thing. So divide by this guy. So I got x equal to ln of 3 minus 4 ln of 2, all divided by ln of 2 minus ln of 3. Okay, I'm just going to punch that thing in. Ln of 3 minus ln of, minus 4 ln of 2. And I'm going to hit enter once, and then divide by, when you do this division, make sure you have parentheses around your denominator. Divide by ln of 2 minus ln of 3. And actually, if you're doing this in one single step, you should also have parentheses in the top. Otherwise, when I punch this into a calculator, I just hit enter once after I do the numerator, and then I divide. Make sure you have the parentheses when you do that division. Okay, and I get x equals to approximately 4.1285. Okay, as a quick check, make sure that your thing makes sense. I'm going to plug it back to the original equation, 2x plus 4 equals 3 to the x plus 1. Just make sure it comes out reasonably close. So I'm going to, because of rounding, it's going to be not totally exact, but I'm going to punch in 2 to the 4.1285 plus 4. Okay, that's about 279 or 280 to the nearest whole number. This guy. And then I'm going to check 3 to the same number, 4.1285 plus 1. Oh wait, 4.1285 plus 1. And it's about 280 if I round. So yeah, about right, makes sense. Looks like my answer was indeed the right one. Okay, sweet. So halfway done with this last question, or really these last 6 questions. Okay, on we go. And you know, for the remaining ones, you notice that in order to solve these, pretty much the logs are all the same base. Yeah, and that's the only type we've really ever addressed, I think. Okay, this is D. Log base 3 of x plus 2 minus log base 3 of x minus 1 equal to 1. Okay. You know, when I see something like this, where I have a minus, you know, whenever you're dealing with logs, your first thought should be, okay, to undo logs, I want to use exponents somehow. And the natural exponent to choose is the exponent that has this as a base. So base would be 3 here. But here I have a little problem. And the problem is that I have 2 separate logs, right? So I need to take an intermediate step and combine those. But what's the rule for combining? If I'm subtracting 2 logs, I can combine into a single log where I'm using division instead. So this is the same as log base 3 of x plus 2 divided by x minus 1. That's equal to 1. Okay, now at this point, then I'm going to hit it with my exponent. So I'm going to do 3 to that equals 3 to that. And on the left side, when I do that, those get canceled out. I have x plus 2 over x minus 1. Right hand side is 3 to the 1, which is just 3. And from here, I just solve like usual. I'm going to multiply both sides by x minus 1. That's going to give me x plus 2 on the left is 3 times x minus 1 on the right. Did I say plus 1? I meant x minus 1. Okay, and then distribute that 3. So this side stays the same. Distributing that 3, I get 3x minus 3. And then let's move the x's to the right. That way they'll stay positive. I get 2x, right? Subtracted this guy on both sides. And then that negative 3 I'm going to add to the left side. So it's going to be equal to 5. And then finally divide by 2. And x equals to 5/2. Nice, pretty answer. Nice, pretty answer. And if you have time, go ahead and plug that back into the original logarithmic. Make sure it makes sense. Make sure you get the correct answer. Well, I'm not doing that because I'm feeling a little lazy. Okay, letter E. Log base 5. Let's do a step instead of just copying the original. So here I'm looking at this equation, right? On the left, it's similar to the previous one where I have an addition this time though. And remember what we do with logs when we have addition, we can combine them into one single log, change it to multiplication. So it's going to be 3x plus 7 times x minus 5, and they share the same log base 5. That's all equal to 2. Now I'm going to hit it with the exponent. It's 5 to the log, blah, 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 is equal to 5 to the second. And then on the left side, when I do that, that undoes the log. So I have 3x plus 7 times x minus 5 equals to 5 to the second, which is 25. Okay, now this step, I have essentially a quadratic. It's factored, but the right side is not 0, so I'm going to have to just FOIL things out. So I'm going to get 3x squared minus 15x plus 7x minus 35 equals to 25. Let's move everything to the left. So subtract 25 on both sides. So it's going to be 3x squared minus 15x. Actually, no, I'm sorry. Let's combine these guys, yeah? Negative 15x plus 7x. That's negative 8x. And then minus 35 minus 25 is minus 60. Equal to 0. Okay. It's not looking immediately nice, but you know, maybe you can let's just try a fact, see if we can factor it. See if this factor is nice. Okay, so I know I'm gonna have a 3x and an x if this is gonna all work to give me 3x squared, right? Okay, I need 2 things that multiply to 60. How about 12 and 5 maybe? Let's see, 12. If I do 12 and 5, I'm going to want the 5 over here and the 12 here. And then I have 3 times 5 is 15, and 15 minus 12 is not 8, though. Okay, so that did not work. What else could we try? We could try 6 and 10. We need to put the 6 here and the 10 here. Oh, yeah, that works. So 3 times 6 is 18. And then 10 times x is just 10. 18 minus 10 is 8. And it was after an 8. So that worked. Sweet. Just write that a little nicer, darker. Okay, now which one should be minus? Okay, I want the negative one to be more powerful, so that would be this one, right? 3x and negative 6 is negative 18. And then this one would be positive 10x. So yeah, there you go. So you guys are listening to my thought process when I try to factor. Yeah, I'm guessing you guys have a similar process. I don't know. You're probably better at this than I am. Okay, so anyways, this is equal to 0 if either side is equal to 0, right? So that gives me my two solutions. 3x plus 10 equal to 0, or x minus 6 equal to 0. Let's solve the easy one first. If x equals to 6, then this whole thing is 0, so check. And over here, this is if 3x equals to negative 10, and then x equals to negative 10/3. Okay, so now that I'm at this stage, and as I'm doing this, I just realized I forgot to do this check for letter D, where I had 5 halves, but 5 halves was, going back to letter D here, let me just erase this real quick. 5 halves, that would make this positive, and that's still positive, so there's no issues with that solution last time. But for this one, we should check, make sure that I'm within the domain, right? And right away, I see if I was to put x equal to negative 10/3 into this right here, I have log of negative 10/3 minus 5. That's a negative number. So that's no good. That one is not possible. Otherwise, if I put 6 minus 5 is okay. And then 6 times 3 plus 7, that's also okay. Those are both positive. So 6 is a potential answer. And I'm going to keep that one. So that means my one solution is x equal to 6. If you want to check it, go ahead and plug it into the calculator with the logs. Or actually, that's not so easy to plug into a calculator as I'm saying that, because you have to use a change of base to punch in an ln or a log base 10. Nowadays, I feel like they should just add the general logs. I don't know, maybe they do that. I know the Desmos calculator, you can do alternative log bases, but I don't know if that's true about general scientific calculators. Okay, this last one, same principle, but you got to combine this one on the left. You got to combine that one on the right. Looks like you're going to have a big quadratic popping out. It's no big deal, though. Here, this is going to be log base 6 of x minus 2 times x plus 1, right? This side is going to be log base 6 of x plus 4 times x minus 3. Remember, addition as separate logs becomes multiplication within one single log. They both have the base 6, so raise 6 to the power of each of those, which undoes the logs. Well, I kind of like that. For once in my life, I like this shading thing here. Okay, so once you do that, the inverse property applies, right? And so you're left with, on the left, x minus 2, x plus 1. On the right side, you got x plus 4, x minus 3. And then you multiply thing out. Got x squared minus 2x plus 1x is minus x minus 2. So is x squared plus 4x minus 3x is plus x. Oh, yay. This is nice because the x squares are going to cancel out, making my job easier. So I thought it was going to be a quadratic, but turns out it's not, because both have an x squared term on either side. So they cancel each other out. Nice. And then let's move our x's to the right where they'd be positive. So I'm going to take this negative x and add it to both sides instead. Add x to both sides. So that's going to give me a 2x on the right. And then now let's deal with this negative 12. I'm going to add 12 to both sides. So that's going to be positive 10. And then x is just 5. Whoa, this one is easier. Even though it's later than E, it turned out to be easier. Now we still should check though. Is 5 gonna have any issues? See, 5 minus 2 is positive, no problem. 5 plus 1 positive, no problem. 5 plus 4 positive, no problem. 5 minus 3 positive, no problem. So x equal to 5 is indeed our solution. Wonderful. And just like that, guys, we are done. We are done with the review. You know, anything that's going to be on the test should reflect pretty much some question. Not to say that it's going to be exactly the same, but kind of same theme, same like, you know, general form of the questions. That's something that we've seen in the review. So if this review is easy for you, then you're in good shape. And if it wasn't, then make sure to review extra the parts that you had trouble with. All right, guys, good luck. I will see you when I see you.